So let's go ahead and get started. My name is Josh. I'm a software engineer here at Oracle, and I work on JSON and XML technology in Oracle database. And I'm joined today with Roger Ford. Roger is the product manager for JSON and full text in Oracle database. And Roger, can you hear me okay?
Oh, yes, I can. And you can probably hear me now. I'm unmuted.
Yeah.
Okay.
So
I'll be sitting here looking for questions on Q&A. So if you have any questions, please post them here. I think only we can read them, but I will pass them on to Josh and we can answer them live, or I'll just type the answers.
Awesome, thank you. So today I'm going to be talking about the Oracle API for MongoDB and the autonomous JSON database. And mostly today, it's going to be a demo. I've just got like, I think 3 slides, but then we'll be doing a demo and we'll show how to load JSON data into the autonomous database and how to set up a small microservice over that data using the Oracle API for MongoDB. And then we'll show how that same data can be queried and analyzed using SQL, and we'll create a little visualization over the data in real time. So the autonomous JSON database, it's the managed version of Oracle database in the cloud, meaning you don't install it or set it up. You just create it and it's kind of there ready to go, and we manage it for you. There's not as many DBA type activities associated with it. And it's intended for building applications that are interactive and mainly need to store JSON data. You can connect to it using MongoDB APIs, tools and drivers, or the normal SQL drivers that you would expect to use in Oracle database. It's in the always free tiers, so anything you see today, you can try in the free tier. If you're familiar with the autonomous database, it's functionally equivalent to ATP, the transaction processing database. So anything you can do in AJD, you can do in ATP or vice versa. The only difference is that the non-JSON data, we limit it to just 20 gigabytes in AJD. You can only scale up the JSON data. So the idea with AJD is that it's intended to provide the same benefits that are typically associated with NoSQL databases. So it's elastic, meaning you can scale the storage and compute capacity as you need to. You can even enable auto scaling so that the storage or compute grows automatically depending on need. It supports low latency access to your data. So we see a lot of NoSQL databases advertise single-digit latency at scale, meaning that they can keep the response time of small reads and writes under 10 milliseconds, even when a lot of people are using the database at once. And so AJD can also do that. And it's highly available, and it's priced to be very competitive with these other NoSQL databases in terms of cost. But then it is running Oracle database, and so it provides a lot of benefits that you may not typically see with NoSQL stores. And this additional benefit that we're going to talk about today is the ability to still query data using SQL, even if you use these simpler NoSQL style APIs to build up your application or microservices. So the basic idea here is kind of illustrated on this slide. You can develop an app or a microservice using the Oracle API for MongoDB. So you work with data as like simple collections of JSON values, not rows and columns in a table, but just like a collection where you can say, hey, put this JSON value in, get the JSON value out, and do simple filtering over it. So you don't need to write a single line of SQL to use these APIs. However, the benefit with AJD is that all the while you're doing this, you don't lose the ability later on to use SQL on that same data if you need to. So SQL, while it may get in the way if you're just wanting to persist your application object and do simple things, like it doesn't add a lot there, possibly. But when it comes to doing analytics and aggregations over your data, it's very expressive and very powerful. So you kind of get the best of both worlds. And I'm about to start a demo showing that. So today, before I start the demo, I wanted to introduce the data that I'm going to be using. So there's a bike sharing company. I think they're mainly on the East Coast of the United States. But they have these bike sharing stations that allow you to check out a bike and ride it around in urban areas and then return it at a different sharing station. So we're not affiliated with this company, but they've done a really nice job of exposing the data about these bike stations as JSON. So we're going to be working with some of this data. So one data set contains a JSON object for each one of these bike sharing stations. So this data set has one object for each station, and it contains information like the location of the station, the name, and the types of payment methods and so on. And then the second data set represents information about the status of that station at a given point in time. So here you have information like the number of bikes that were available at a given point in time. And so each station has multiple objects in this status data set. And the two data sets join together on an attribute called station ID. So it's like a key foreign key join here. It's a one-to-many relationship. So for the demo today, we're going to load these bike station data files into AJD. And to do that load, we're going to use MongoDB's import tool called Mongo Import. And then we're going to connect to the database using their command line tool called MongoSH and show how you can interact with this data as a collection of JSON documents. Then we're going to stand up a simple little REST service over this data. And then we're going to analyze and visualize that same data using SQL JSON. So as I move through this demo today, I'm going to kind of try to focus on the interesting parts and maybe skip some of the steps. But if you would like to do what you're about to see me do, I put all of the step-by-step with all the details that I may not show here on GitHub, and that's on this link here on the slide. And I'll give this link again at the end of the talk. But so you don't need to worry about trying to follow along or anything like that. All the steps are here if you find this interesting. Okay, so to start out, this is Oracle's Cloud Console, and you can go sign up for this for free. It will ask for a credit card if you there's a link at the end. But if you try to sign up, it will ask for a credit card. It won't charge you ever, even if you do nothing with it. I've given it several of mine credit cards, and I've never been charged. And I use a personal email address, so it doesn't know that I work here or anything. So it does seem pretty safe. I know there's always some worry that you're going to get charged later on, but you really can do all this stuff for free. So I'm going to click up here on this hamburger menu and click on Oracle Database and the autonomous JSON database. This is AJD. And so if I were to click create, I could create one of these. It asks minimal information about the database, the name, username, and password, and things like that. And then it takes about a minute to create one. But I have one created here that I'm going to use for this demo. So this is my database, and we're going to start by using the Oracle API for MongoDB. So I'm going to go get the connection string for that in the service console, this button right here. So I go in here and then I click on development. And at the bottom, there's a card titled the Oracle API for Oracle Database API for MongoDB. So there's two connection strings here. One is if you're using older clients, really recommend use the first one if you can. And if you hover over here, it tells you the minimum driver versions in order to use this first one. So I'm going to take this connection string, and now I'm going to go and use it as input to Mongo import and export to load this byte data. So first I'm going to take this connection string and set it to a variable called URI, just so I don't have to retype it as I'm working here. Okay, so the first thing I'm going to do is import that first data set that I showed you on this slide. So here I'm using this command called curl. Curl just grabs the data directly from their web service about these stations. And then I'm using a command line tool called JQ. And this is doing two things for me. First, it's pulling out the nested station objects about the bike stations. And then it's taking their station ID attribute and it's renaming it to _ID, because this is the ID name that MongoDB clients expect. And then I'm taking the result of that and I'm piping it into Mongo import. And so it's going to send those bike stations into Mongo import, which is taking this URI that we just set up here as input. So if I run this, it says we've loaded 1,623 documents because there's 1,623 bike stations. So we're going to do the same thing now for that second data set. And so here in this case, I've just got some of those records saved in a file. So we're loading this into a collection called status. And so now I've loaded 20,000 of those station status records. Now I'm going to connect using Mongo SH, the command line tool from MongoDB. So I pass in the username, the password, and that connection string. So now if I type show collections, see I've got these two collections we've just loaded. And so now I can do most of the same stuff that you'd expect to be able to do in MongoDB. So for example, if I call station.find, it dumps out some station objects like the one that you saw on the slide. You can also do these query filters. Oops, sorry. Wrong one. So here I'm doing db.station.find, but I'm passing in a query filter, sometimes called a query by example, but you give it a little JSON object that looks like the data you want back. So this is only going to give me records where the ID attribute is equal to 497. So here we get back that single station, and you can do things like updates. So here I'm finding the station with ID 497, and I'm setting the capacity to 77. So currently this capacity attribute here is set at 66. And this command is going to set that to 77. It's going to update this document. So if I run that find again, you see that capacity has changed to 77. So you can do most of the same things you'd expect to be able to do in MongoDB by connecting to this this endpoint. So what I'm going to do next is I'm going to start up a small REST service over this data. And to do that, I'm going to use a framework called Spring Boot in Java. And if you're thinking that you're not into Java or you don't like Spring Boot, don't worry, I'm really not going to focus much on the details. The point of this is really to show that AJD is well suited to this use case, to this interactive use case where you want smaller requests to be very low latency. So all the details here I put on GitHub, this link I mentioned. And so Spring Boot is what they call an opinionated framework. It assumes a lot of defaults and conventions that make it so that you can write very little code to stand up a REST service. A surprisingly little amount of code. So the main thing I had to do to the code to write here is I first created these model classes, which are these plain old Java objects. They're just regular old Java objects, and there's nothing too special about them. They just have a member for each of the fields in the JSON object. So there's one for this station, and then there's one for the status record. And then the only other thing I did here is I created these repository implementations. So here's the one for station. And so basically this is doing two things. One, it's extending the Mongo repository, which is from MongoDB's Spring data adapter for this station POJO. And so that defines a bunch of operations automatically against this station data. And then we're using this annotation here that tells Spring Boot to expose methods about this repository as REST endpoints, so that when we start it, we'll get a bunch of REST endpoints that we can call to interact with this data. And that's basically it. And like magic, we start this app, and we have a bunch of REST services to interact with this data. So I'm going to go back here. And build this service. So now it's compiling and packaging up all of this Java code. And the output is mainly this runnable jar here, bikes.jar. And so the next thing I'm going to do is I'm going to start the service up. So I'm calling the Java command, pointing it at this jar, and I'm sending in this same connection string that will tell the MongoDB Spring data adapter to connect to AJD. Okay, service is started. Okay, so now I'm going to use this program called Postman. So Postman is just a tool that allows you to submit REST requests. So the first one I'm going to do is send a REST request for station to get station 497, just to test that the service is working. And it seems to be working, so it gave us back one of these stations. And we can also do get the status records for the same station. So here, if I do the GET request, it's going to give me all the status records for 497. So here we'll should get multiple objects back. Here it sends back a bunch of results. It also has endpoints that I can call here to update this data and change it, but I'm going to come back to that in a little bit. The other thing I wanted to show here is I've seen several customers use a tool called JMeter, which I have up here, and it's a tool that lets you kind of poke at the performance of your service. So I have a very simple one of these JMeter tests set up here for this service. So here it's going to do a REST request to get station 303, and then it's going to insert a status record about station 2003. So it's just going to do two REST requests, and it's going to spin up a few threads and run them. So if I run here, I think that's going. So it should be spinning up threads now and running them against this REST service and measuring the response time of them. So if I click here, it's bigger. So, occasionally it gets a little bit better too as it warms up, might pop slightly up above 10 milliseconds. And this is the overall response time of calling the service and calling the database and returning to this tool. But down here, you can see in blue that I'm averaging for these operations about 7 milliseconds. So it is very interactive and very responsive. And this is admittedly kind of a trivial test, kind of small. But we've also, are constantly looking at more serious tests like YCSB, kind of notable NoSQL benchmarks. And as long as you provision enough compute and enough database capacity for your given workload, you should be able to scale up and keep these response times low. Okay, so so far in this demo, I've loaded this JSON data into collections, and I've started up a microservice over that data. And in doing all this, I've not had to write a single line of SQL to do that. But I'd like to switch gears now and show that even though we've done this, we've built this app without using SQL, that we still can use SQL if we need to. So I'm going to go back into this web console from my database here. And I'm going to click on this button here, Database Actions. So Database Actions is a nice web-based tool that lets us interact with the database from a web browser. And it has ways we can submit SQL and do other kinds of things. There's all kinds of features in here. Like, for example, there's a JSON workshop page here. If I click this, you can see our two collections there. And so I can do that. And do the kind of same filtering that we saw earlier to query the data without using SQL, work with it kind of in a UI and a collection-based UI. But that's not actually what I want to show today. I'd like to go to SQL Workshop. So SQL Workshop lets us submit SQL queries against this database. And on the left here, you can see it's showing me that I have two tables that match the names of our collections, station and status. If I expand these two tables have exactly the same types of columns. They've got the ID and some housekeeping columns, like when the value was created on. But the main column is data, and data is storing the JSON documents that we just loaded. And what this allows us to do is query this data from SQL. So the first query I'm going to do is this one. And so I'm selecting the data column from the station attribute. And down here, you can see the JSON objects that we just loaded. I'm calling this function JSON serialized because we store that data in the database in an efficient binary representation called OSIN. And so JSON serialized just says, take that OSIN and return it as a text value so that we can see what it looks like. But you can do much more than just return the values from SQL. You can actually project them out into relational rows and columns. So here I'm selecting from station, but I'm dotting in to that JSON column and then selecting the JSON entries out, and so that they come back as relational rows and columns here. So now at this point, now that you have this, there's absolutely no restrictions on what you can do with this query. You can do any kinds of joins or aggregations that you're used to doing in Oracle SQL. And you can join these JSON values directly with other types of data as well, like XML, relational, and graph. You get the full power of the converged database. Dotting into the attributes like this is great if you only need to do a few and you know what you want to select. We also have a feature, actually I'm getting ahead of myself. Let me show one more. So this is kind of doing the same types of simple dot expressions here. But now we're doing a group by query. So it's grouping the region ID of these attributes and counting how many they are. So if I run this, it does a group by query. So I can see here, I've got 28 stations with region ID 311, 1,542 with region ID 71. So the next thing I wanted to show is that we have this feature called Data Guide that can actually figure out what the schema of your data is automatically for you. So what this is going to do is it's going to introspect the JSON data and automatically create a real-time relational view over that JSON data. So I'm calling this create view function here. I'm saying I want you to create a view named station view, and I want you to look at this table called station, and in that table, the column called data, and automatically create this view for me. And it's going to do it for both of our collections. And so now if I click over here on views, you can see I have these views with all the JSON attributes represented as columns in the view. So if I now select from one of these, see here all of the attributes from the JSON are automatically produced as columns. And so it's not materializing any data here. This is just a view directly over the JSON data. And so now we can start to do things more interesting. So the next thing I'm going to do is I'm going to join these two collections together. So I'm selecting out the station ID. I'm joining to get the name of that station. And then I'm computing the min, max, and average bytes available for that station over the period recorded. And so here we see what the result looks like. We've got the station ID, the name of the station, the minimum bytes that were available during the period, the maximum, and then the average. And I'm going to keep working with this query here, but first I'm going to turn it into a SQL view, just so I don't have to retype that. Oops. So I'm going to create a view called station availability. It's defined by this query. So now instead I can query that view. It will look a bit simpler. So I'm selecting the station ID, the name, min, max, and average. And I also added a where clause here, where the minimum was greater than 20 and the average was greater than 50. So I added this just to, because there was a bunch of rows returned by this, and I wanted a fewer number of rows for what I'm about to do next. But you can think of this as returning like stations that during this period had a lot of bytes available. So I'm going to take this now, and I'm going to click back up here on this hamburger menu and click on charts. And I'm going to create a chart based on this query. So the type of chart I'm going to create is a bar chart. And on the x-axis, I'm going to have the station. Y-axis, I'm going to have max available. So let's change that to name. Select max. That looks good. I'm going to click create. So now I've got this nice visualization of these 6 stations and how the maximum bytes that they've had available during our recordings. But this is absolutely a live view of this collection data we have. And so to show that, I'm gonna, so I can here, if I click here, instead of showing me as a bar chart, it'll show me the station IDs. So in particular, I think I'm going to work with station 303, this Mercer and Spring Street. Now, if I go back to Postman, I'm going to insert a status record for this station 303. And that status record is going to say, suddenly there were 200 bytes available. I click send, it inserted, it posted this record into the data. And so now if I come back and I refresh this, it updates immediately because this is a live view of that JSON data in place. So I come back here, I've got a delete method. I didn't show it, but there's a little bit of code that sets it so that if you delete a station, it'll transactionally delete all the status records as one, right? So the station and its corresponding records and the other collection will all disappear from outside viewers at the same time. So if I delete 303, go back again, same deal, it's gone. So it's really neat because you can get this same, build up an application or microservice and have this low latency interactive application with your database. But at the same time, you can still do stuff like this. You can make these kind of more complex reports and analysis of your data. So this concludes what I wanted to demo today. Just have one more conclusion slide. So yeah, so you kind of get what the features you'd expect from a NoSQL database, but you still have all the enterprise features like transactions and reporting and SQL that you'd expect from Oracle database. So there's a few links here. This QR code goes to this link at the bottom. If you wanted to repeat what you saw here, I put step-by-steps on how to repeat this on this GitHub page. There's a link that's a nice link on getting started, a blog written by Roger. And then this is the main page for the autonomous JSON database. Okay, yeah, so thanks everybody for joining us. Were there any additional questions? Roger, if you're talking, you're muted.
Yeah, I am. Beg your pardon. Yeah, we had one question. I wondered if you could go back to the JSON data guide statement in the SQL. The question was why we call JSON data guide twice. So I replied that was because there were two collections and we're calling data guide once for each collection. But perhaps we can show that just to make it clearer.
Right, so we have the two data sets. These are the two tables backing the collections we loaded. So this data guide example, I probably went too quick here, is in two parts. So the first one, it's selecting from station, the first data set, and it's creating a data guide in this variable DG, which is kind of it goes out and it's broken into two steps here. So it's going out and it's creating this description of the schema of that JSON data. Because unlike tables, right, with JSON objects, you don't, the attributes of these JSON objects can change row to row. There's no requirement that, if one row has and one object has a field called number of bytes, that the next object has that same field. It's schema flexible. So it's creating a description of this data as it is right now in the database, and it's storing that description of the schema into DG. Then it's calling create view, and it's creating a view given that description of the schema for the station table. So these two together are creating the view station view. Then it's repeating the same thing for the second collection for status. Now, these next two lines would create the second view.
Yeah, I think that's clear. Thanks for that. And the questioner confirms that he missed the different table names.
Okay, cool.
Yeah, so I think we're all good. Thank you for that.
Okay, great. Yeah, so if you think of questions later, feel free to email me, or I'm trying to get more into Twitter. I only have a few followers right now, so if you want to follow me on Twitter, I would appreciate that. And yeah, so thanks a lot for coming.
Thanks, everyone.